Let's continue with the binomial theorem. The first important point about binomial theorem is the statement of binomial theorem. Let's see that. Let's see. If A comma B belongs to R and N belongs to natural numbers, then the expansion, the most basic expansion of in the case of binomial theorem in this chapter, A plus B to the power N. This expansion will be, I'm writing it here, NC0, okay, A to the power N, B to the power 0, plus NC1, the second term, A to the power N minus 1, B to the power 1, plus NC2, A to the power N minus 2, B to the power 2, plus this sum will continue up to NCN, okay, from 0 to n, A to the power 0, B to the power n, and the sum of this can also be expressed as summation NCR, okay, A to the power n minus r, B to the power r, and this r is varying from 0 to n. So you can identify each of the equations, like each of the term. So first of all, if r is 0, then you put r 0 in here and here and here. So you will get NC0, which is this term, A to the power n minus 0, which is A to the power n, B to the power 0, this term. So this is our first term. For r equals to 1, you will have this thing. For r equals to 2, you will have this thing. For r equals to n, you will have this thing. So this is the expansion of A plus B to the power n. So this can also be written as summation NCR, n is this, CR, A to the power, which is the first term, A to the power, okay, n minus r, B to the power r, okay, this B to the power r, which is the second term, and r will be summed from 0 to n. So this is, you got to remember. The next formula for this topic, that will be the properties of binomial theorem, okay, properties of binomial theorem. Now, first property is the general term. For this A plus B to the power n, the general term will be TR plus 1, okay, is equals to NCR, A to the power n minus r, B to the power r. For the general term for the expansion of x minus a to the power n, this for x, a plus b to the power n, okay, this is for a plus b to the power n. For x minus a to the power n, for this you will have TR plus 1 is equals to minus 1 to the power r, okay, this will be r, NCR will be there, okay, then you will have x to the power n minus r, this x, which is the first term, and a to the power r. This will be the same, you will just have this thing in front of this, okay, so you will have this as general term. So binomial theorem, the general term for this will be this, okay, and you can derive this from this. So you have to just remember this one, important. Then you have the second one as the middle term. Middle term. Middle term. First, if n is even, then there is only one middle term. As you can see, it's really simple. One middle term, which will be n by 2 plus 1 th term. Sorry, 1th term. Now you can just see that if you have 1, 2, 3, 4, 5, 6 and 7, if you have these terms, then these three will go, and you have a middle term, okay, which will be 4th, okay. So if if you have odd, you can easily identify the B case. But if you have even, like you have 1, 2, 3, 4, then how you will identify? Then you will identify as third term. Okay, there is only one middle term. If n is odd, then there will be two terms. Okay, so if this is for this case you will have two terms. If n is equals to even, then you will have two. If n is equals to odd, then you will have two middle terms. I'm sorry, this is not even, this is odd. Okay, in that case you will have four terms, because the nc0 plus nc1, these terms, plus up to ncn, these were n plus 1 terms. Okay, so if n is even, then this will be odd. If n is even, then this implies this will be odd. So that implies total number of terms is odd. That implies this case. Okay, so n is even implies this case, n is odd implies this case. So if n is odd, then you will have two terms. One of them is, let me write it with green pen. One of them is n plus 1 by 2th term, and other one of them will be n plus 3 by 2th term. Okay, these two will be the middle terms. If n is even, then you will have n by 2 plus 1. If n is odd, then you will have these two terms as the middle terms. Now we'll move on to the multinomial theorem. Multinomial theorem. In this case you have many variables. So like x1 plus x2 plus x3 plus up to xk to the power n. Okay, this will be summation r1 plus r2 plus r3, plus up to rk, it will be k. So the summation from r1 to r2, r1 plus r2 plus r3 plus r4 plus r5 plus r6, that will be up to, you can say up to rk, that will be n, and in here you will write n factorial upon r1 factorial into r2 factorial into r3 factorial up to rk factorial. Okay, this into x1 to the power r1, then x2 to the power r2, then x3 to the power r3 up to xk to the power rk. This is the multinomial theorem. This is really big. So what do you have? If you have k terms, x1 to xk to the power n, then what will you do? r1 plus r2 plus r3 plus r4 is equals to n. You will sum up to this n factorial, which is divided into k, r1 to rk. So n factorial upon r1 to rk factorial, then into x1 to the power r1, x2 to the power r2, x2 to the power x3 to the power r3, and you will multiply these k terms. Now the next one is application of binomial theorem. The multinomial theorem is not of much use, but you have to remember it. One more thing in case of this is that here total number of terms in this expansion is equals to n plus k minus 1 c k minus 1. Okay, this is the total number of terms. This is mainly asked in JEE, that how many terms are in this multinomial expansion. So you will just calculate this value, n plus k minus 1 c k minus 1. Now we were going to read application of binomial theorem. So if root a plus b to the power n is equals to some integer plus some fraction, okay, where it will be always, so where I and n are you can say positive integers, n will be odd, and f is a fraction, so it will be between 0 and 1, then I plus f to the power, this I plus f to the into f is equals to k to the power n. Okay, where a minus b square will be k, which is greater than 0, and root a minus b will be less than 1. So when you multiply this root a plus b with this root a minus b, you will have a minus b square. That will be k, which is greater than 0, and k to the power n will be I plus f into the fraction term again. Now if this is all when n is odd, but if n is even, then I plus f into I minus f is equals to k to the power n. Okay, you have this formula and you will solve it like this. This is also not much important with considering JEE. So the next will be, this is most important, these 5 properties which I am going to tell you right now, these 4 properties. These are the binomial properties of binomial coefficients, which were NC0, NC1, NC2, summation up to NCn. These are the coefficients of every binomial term in the expansion of a plus b to the power n, as we saw. So the summation of these all n terms is 2 to the power n. Okay, now second term, second formula, how is this possible? We'll see that. Let's just see that. We have seen that a plus b to the power n is nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus up to ncn a to the power 0 b to the power n. Now when you have these term as 1, these terms, okay, we have only coefficients, that means a and b both are 1. So that will give you this as 2 to the power n, and this as nc0 plus nc1, this will be 1, this will be 1, plus nc2 plus this will be also 1. So you have ncn. So the summation of these coefficients will be 2 to the power n. The next set of properties will be alternate sign. Okay, let me write it here. Second property, that will be nc0 minus nc1 plus nc2 minus nc3 plus, okay, up to plus minus 1 to the power n ncn. This is always 0. Okay, now I don't need to prove this property. Okay, you can easily do it by putting b as minus b and a and b as 1. You will get 0 on the LHS. Then third property, all these properties can just be proved like what I did for the first property. So this nc0 plus nc2 plus nc4, these are generalized result and are directly used in JEE, so you have to remember these. Okay, up to some value. Then you have nc1 plus nc3 plus nc5 plus up to some value. Fine, these two are equals to 2 to the power n minus 1. These are just half, okay, some of the even coefficients and some of the odd coefficients. These two are equal and are equal to 2 to the power n minus 1, which can be written as 2 to the power n by 2, which is, this is the total sum divided by 2. Okay, so this can be easily remembered. Fourth property is NCR plus NCR minus 1 is equals to n plus 1 CR. This is also extensively used. Okay, NCR, which is n factorial upon r factorial n minus r factorial plus n factorial upon r minus 1 factorial plus n minus r plus 1 factorial is equals to n plus 1 factorial. N plus 1 factorial upon r factorial n plus 1 minus r factorial. Fine. So this is one of the most important identities of this chapter, and if you know these formulae, then you can just derive it. But this property is directly used in many questions in JEE. I have also used it. So and then you have NCR upon NCR minus 1 is equals to, this can also be derived, N minus R plus 1 upon R. Okay, this can also be derived, and this is also used in many questions, many questions. Now, the next will be binomial theorem for negative integers or fractional indices. This is also, important. So I'm going to write it with another color. This is important. The expansion of 1 plus x to the power n. This is equals to 1 plus nx plus n minus 1 by 2 factorial x square plus n minus 1 n minus 2 by, of course, 3 factorial x cube. Then this is added up to n minus 1 n minus 2 n minus r plus 1, this is into, okay, upon r factorial into x to the power r. If you remember this term, which is the rth term, you can derive all of these terms by just putting the value of r as 0, 1, 2, 3, 4, 5. Okay, so this is the rth term plus this will go on to infinity. So the tr plus 1, which is the rth term, that is equals to n minus 1 n minus 2 into n minus r plus 1, okay, upon r factorial into x to the power r. This is the rth term, okay, this. So this is the binomial theorem for negative integer or fractional indices. If you have 1 plus x to the power 1 by 2, you have to expand this, or you have to expand this, or you can have 1 minus x to the power minus 1 by 2. Then you have to just use this formula. You have to put the value of n, this in here, and you have to just put x as this. If you have minus x, then you will put x as minus x in here, and in here also. Okay, so you will get the expansion. This is the general expansion of 1 plus x to the power n. Here we complete our binomial theorem.